What do you think? Which one? Well, let me read. Let's try it this way. I'm gonna read the sentence. Someone tell me if that's yours. The blank of a data set is the sum of the values. The sum, that's important. Put a plus sign. Divided by the number of values. Who are you?
Mean.
All right, mean is correct. Boom. Good choice. All right, second one in line. Hey, the blank. Oh, same word twice, not two different words.
I'll tell you that.
Say again?
I was going to tell you, like, do we use the same word for that one?
Yeah. So let's find out. The blank of a data set is the middle. Oh, yeah. Value, circle that. That's important. When the values are written in numerical order, that's a way of saying from small to large, large to small. Usually go small to large. If a data set has an even number of blank, well, let's just take the first sentence because that one is the definition. Now, where is that? What do you have?
Median.
Median. Median means middle. When you're driving, the middle of the road, the double yellow in the middle sometimes, or the island in the middle, is the median. It says here, though, if a data set has an even number of values, that means there are 10 of them, 8 of them, which we did on that one sheet before, which we're still going to put on here just as a quick review. The blank is the mean of the two middle numbers. That's the way of saying is, if you start coming from the outside to the inside, and there are two guys left on the inside, the median is halfway between those two guys in the middle. Well, how do you say halfway between two guys? In math talk, you say the mean of two middle values. Halfway between the two middle guys is the mean of those. So again, you are right. It is median twice. For that one. Down to the next sentence, the blank of a data set is the value that occurs most often. Most is the magical word there. What is that word? Ooh, I don't know what that blank is for. Same word. Who has the number that shows the most?
Is it a mode?
So whoever has that one, you are right. Let's see what the rest of it said. A data set can have no mode. That is 1, 2, 3, 4, 5. Okay, all the numbers show up the same amount, so that's no mode. One mode, 1, 2, 3, 4, 5. Okay, 3 is the mode. And then, of course, more than one mode. 1, 2, 2, 3, 4, 5. 2 and 3 are modes because they both show up more than the others, but not more than each other. And then that last guy right there, it still works out. The blank of a data set is the difference, that is a subtraction, of the greatest value and the least value. What is that one?
The range.
The range. Range statistics, of course, is different than the range in terms of algebra and graphs. It measures out how spread out the data are. Now, put how spread out the range. From little kids to grandparents, they love Disneyland. You know, it has a big range. For maybe teenagers to 35-year-olds, they like Magic Mountain. And then from 80 to 95, they like the San Diego Zoo. All right, so that's what we have there. All right, we're doing number 1 and 2 as much as we remember. Then I'll do them all together. I'm talking to the video people. And I'll write mine down so that they can see it, though. For you, you can just punch it in the calculator. And then trying to find the average or the mean as is statistics. They're just always trying to organize it in some way that you don't have to pay attention to all the information you're given all the time. So if I say the average student that goes to options is probably a 17-year-old, when people are thinking about students who go to options, they can start thinking, okay, 17-year-olds. Yeah, there's some 14-year-olds. Yes, there are a few 20-year-olds. And there hasn't been a 21-year-old student here for a while, because usually by the time they get there, 1, 2, 3, 4, 5, 6. By the time they get there, they're ready to switch out. So That part is done there. Okay. I'll ask for this one in a moment. I'm going to use some math writing. Ooh, someone may know. They may have been in that class. There is a way we can write a letter to say that it is the mean. Anyone know how to write a letter to say it's the mean? It's something we do to any variable. Say it's the mean. Yes. I want to be able to say a couple of things that are brand new. It's going to be an X with a bar over it. I wonder if I move this thing, is it going to go up or down with me? Put these in order from each equated so that at least Oswaldo can get a little help on that one. Someone say what the lowest number is?
720.
All right, 720. Someone different than the next number? Or
1325.
1325. Someone different?
1494.
1494. Someone different?
1656.
Yeah, and I guess at this point, whoever chimed in, I'll do 1656. Next one.
1874.
1874. Someone else?
1990.
1999.
There's two of those.
Two of those. They want to
2949.
Is it the last guy?
Yeah.
Good, because I'm out of space. 2949. All right, and for Oswaldo's, so just in case there are even number of them, is there an even number? I just start cutting off the edges.
There's even
There's
number.
two.
Okay. And so these two guys in the middle, to get that, you're going to add, and always divide by 2 to find the mean of anything. You add those things together, and however many of them there are. Well, there are only going to be 2 in the middle, so the median, if they're even numbers, always divided by 2. While he messes with his, that back table, Tina and Marcos, what is the mode or modes?
1999.
1999 is the mode. And again, in statistics, the mode can be important. In other words, if someone said, hey, Thomas, what's the mode of the number of units that students will turn in? Here are options for you. I would say, well, the mode is 4. 4 is probably the largest number that students will tend to turn in. Now, the range is going to be from 10 all the way down to 0. So there's a wide range. But the mode lets you know, okay, most students are doing 4. So 1999. David and Jessica, what is the range? Oh, I don't know if I gave time for that one, but now that we've written it up for median, which I'm going to go to median, then I'll come back to range, if you remember range. If you don't remember range, then we'll get someone to help us out. But
Is it 22.29?
range, 22.29.
Yeah.
Yeah, it's going to be that. I can see the big, big minus small. So I can see that 29 reaches over here, taps a little friend on the shoulder. Say that number again, please.
22.29.
22.29. And then, oops, that's the range, 22.29. Anything on that median, Oswaldo?
I got 17.65.
That seems about right. I know 17 is between them. 17.65. So again, you're messing around with statistics. What is statistics in a large part? It's how you manipulate data. And by data, we usually mean some type of numbers. Count up something so we can tell the people how many of this is happening in the city. How many people are doing one thing or the other. Anybody needs this any longer? Because unfortunately, to go on to the next thing, we have to erase it. All right. We will talk about that last thing down there. They don't have us do much to ask for the average. On the next one, the only problem is there are 2 ways to consider it. Now, I feel like I've seen this done more than one way, and that is find the average of these numbers with the outlier, and then find the average or the mean of these numbers without the outlier. Anybody know in this particular problem what the outlier would probably be? Yeah. So this is An outlier in this case, I was thinking of like a little kid's birthday party. Of the people who were invited, clearly this party is probably for like a 2 or 3-year-old, but this dude came. Now, he's nobody's parent. He's not bringing one of the kids. He's like all showing up in shorts and whatever. So it's a little creepy. So an outlier can be thought of in that sense. The other version of outlier are like superstars. So let's say Bill Gates or Mark Zuckerberg, people that's created stuff, or Michael Phelps or whatever. They're outliers because they're so far out of the group. So outlier, let me see if I can mark any keyword here. Observation that is well outside of the expected range of values or experiment, which is often discarded from the data set. That part is worth double marking. In other words, if we want the average age of the kids at this party, the question is, should we include this 20? That when we add them all up, will make the numbers seem bigger. As a matter of fact, let's do both. Or if one person is willing to do that extra one, the rest of us, let's get the mean or the average of the data without the outlier. Who's willing to do it with the outlier so we can hear how big it's going to throw it off? Get your calculator. Anybody willing to say, yeah, I'll do the outlier version. I'm going to get the mean. It's just punching in one more number for whoever's going to choose to do it. All right, Tina's going to do that one. The rest of us, go ahead and add in these guys. By the way, what's the mode in this set of numbers, set of data? Let's do this.
Just the mean?
Yeah, this one looks like it's just asking for which averages best represent data. Which number would be the outlier? We got the outlier. We know that was 20. The old dude, well, he's 20 years old, so he's not an old dude, but certainly compared to the kids there. So we're going to get two means. I'm going to put M1 bar over, what's the word, a variable means the mean. You got to get used to the notation, so when we get down to standard deviation, it won't throw you. And then I'll put, the mean 2 with outlier. Whenever the other group gets the original without outlier, say it. Again, I'm going to add, how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9.
2.2 repeated.
Oh, for real? That's without the 20, correct?
Yeah.
And then with it is 4.
All right, 2.2. I'll put a bar over the 2. And that's unfortunate because now this bar just means it repeats. This bar means on the average. So with letters, I guess the letters can't repeat. Heard it said again before, who? Just 4?
4.
Straightforward. And so again, the bottom one says with outlier. The bottom one says, hey, the average age of the kids that were at the party were about 4. So pretty much if you look around the room and you point it, you're probably going to be pointing at a 4-year-old, which isn't true. This one, kind of more, they're about 2-ish. If you point around the room, chances are you're going to point a kid who's 2. Well, you got a better chance of pointing at a 2-year-old than a 4-year-old, since there's only one of those there. So again, what are some of the words I just want you to have in your pocket? Boom, outliers, one of the new ones, which just means oddball. Oddball good, oddball bad, but it's definitely not part of the group. So like at off sometimes you see some kid turning in 10 units a month, like all the time. Like I had one student, she's done it 2 times in a row, and she has pre-calculus, she has physics. She would be considered an outlier. Like, how do you turn in 10 units? And it's not like they're all just the easy ones. Now she has some of the easy ones. She's had health, that's true. But you mix in health with pre-calculus, with physics, and the English, the packet version, which is pretty intense. Then you're like, whoa, okay, you're kind of an outlier, but she has a reason why she's here, and so on. Let's see what we have here with standard deviation. Standard deviation are 5 steps. And again, it's all about data. These numbers here represent ages of people, the number of people who have different types of jobs or whatever. Whatever the data is, and by the way, data can be plural or it can be singular. You have one piece of data. You have several pieces of data. Like I have 1 student in the classroom. I have 5 students in the classroom. Data doesn't change. If you want to be specific about one, I feel like you can say datum. You have one datum, but again, usually we just use data just to be a single or plural. So step one, find the mean. This is let's do it. Let's mark it on here. We'll come back over here to see how they did that and how they marked it. So step one, you're going to find the mean, x bar. Now we're not going to do it on this one yet. We're going to look at the other one when I switch over to it. But I just want you to mark it on this form that you have. Step two, find the distance each data value to the mean. Find the distances of each data value to the mean. In math talk, that is, do a subtraction problem. How far am I away from Oswaldo? If he was at 1 and I was at 10, 10 minus 1, no, I'm 9 feet away from Oswaldo. So how do you write, find the distance of each? Now I need to double check to see if they put the mean first and then subtract, or do they do it the other way? They do it the other way. So my distance away from Oswaldo, Oswaldo is the mean. What's my distance away from the mean? Mean minus what the original mean was. Step three, square each distance value. In other words, the answer I got from this guy, I wish I could actually change that color so that they can feel a little difference. Square each distance value. In other words, I'm going to take this whole thing, whatever this answer is, and I'm going to square it. How do I show that? I'm going to put a parenthesis. Well, let's do it right below it. See if that doesn't confuse anyone. Put it right below it. And whatever that is, when I do that subtraction problem, I'm going to raise that to the second power. Standard deviation. And then I'm going to find the mean of the squared distances. This one is a little tricky. Let me see how they write this one. We have to find out how many numbers we were using. In this particular problem, if I went up, there were only 5 numbers. This is how we write step 4, and now I'm running out of space. Let's see. Step 4, we take this thing here, find the mean. How did they write that guy? No, I'll just put find the mean of the sentence. I'll just write this one in words. Yeah, I know they have it. I'll write it this way and see if we're okay with it. We're going to put that in there and divide it by n. I feel like there will be a piece missing, but I'm still going to write it this way. All divided by the letter n. N in this case is the number of how many of them there are. So n is, maybe I should put that part, number of data. Do I have 5 things I'm talking about? Did I have 10 of them to begin with? And then the final thing you do, you take the square root of the whole thing, like everything. So I'll put square root step 4. Square root, on the set, square root step 4. Whatever you get for step 4, you square root. So finding the standard deviation, just even hearing these words, you're head and shoulders above most students here at the school, and just kind of knowing what it really means. How far am I away from the mean, the guy in the middle? When I compare myself to him, am I below him? And if so, am I 1 away from him, 2 away from him, and so on. All right, let's look at the example you have on your other paper to be your example in this one. I'm trying to say about the project we're doing, or the work we're doing for this unit. Can I get an example? That's how education works. You give me an example. I study the example, I follow the example, and then if I have to do that version of it, then I do that as well. All right, so here it is. And you're about to do something quite similar. Step 1, and I wish we could put a 1 next to it. Can I make you larger? Can I make you larger? If I do, will that mess things up? I'll keep it as is. Step 1, sure, I'll put step 1. Find the mean, and you can see here they got the x bar. Here are the numbers in their data set. They got 1, 2, 3, 4. Hey, somebody's missing. Oh, do me a favor, squeeze in your 50. It must have gotten cut off. Wait a second. No. The 2 53s. Can someone tell me what number's missing? It's not my 50 because that's the answer. There are
It's the 49.9.
49.9. He's the guy missing. All right. Otherwise, that 5 would have needed to be a different number. It would need to be a. Oh, okay, thank you. That was a weird thing because I was going to be like, the bottom number needs to be 9. No, it needed to have been a 4 if they're there. All right, so step 1, we got find the mean. Now, they did organize in the chart, which I'm going to recommend to you as well when it's time, so that everything can be organized. So here are the 4 x's, the 4 original numbers that were given. Okay. When we get our 50, our mean, there it is, our x bar. I don't know what color I didn't know it was there. I may have had you red, which ultimately may not matter, but now I can't stop myself. Nope. Let's see if I can do it one last time. We'll switch the colors, and then we'll just keep going. All right. This row here are the numbers that are given. You see your 48, your 53, no big deal. This row here is the mean. To get to step number, is it step number 3 on the other list of paper? What step is the find the distance on the other sheet of paper?
2.
All right. So step 1, find the mean. Step 2, I'm going to put an S2 above this line here. S2, or step 2, is going to be to find the distance. And I'll even put distance below that. So say they're using keywords. And notice, I wish I could write, I'm going to write 1 on the side. I'm going to write that 48. That 48 goes first. Minus that 50, which goes second. And then hopefully you can see that that equals that negative 2. Okay. So here it is right here, this line here. The next step that they're going to do, well, they're going to do that for each one of them. So when you do step 2, or rather, yeah, when you do step 2, you will do it for all 5 figures. After that, and now it's, I feel like it's too many steps, but I'll still say the next step. Whatever answer you got step 2, step 3, you're going to square that. So you'll see here, step 3, whatever was in there, that negative 2, you squared it to become a 4. Everybody in your calculator, do me a favor, do 3.2. Hit the x squared button. Let's see if it just jumps it up to 1024, or do you have to do negative 3.2 times negative 3.2?
No, you just do 3.2 squared, and it's 1024.
Okay. Did you hit the x of the second power button? Okay. So you can do that when it's time to square the number instead of having to go 3.2 times 3.2. All right. That's step 3. But let me pause there. Help find out. So we're finding out step 4, I believe, which is to find the mean of these square distances. I'm going to ask someone to try and add them, try and write them down here in this little small space, which is a bad idea. So maybe I should put step 4 over here. Step 4. I got to start adding some numbers together to get the mean. 4 plus a 1024 plus a 529. I'm finding the mean of that last column plus an 1156 and a 0.01. Okay, I'm trying to get to the end of this one and have you guys do it. All of this is going to be divided. How many numbers were there altogether? There's 1, 2, 3, 4. All right. All divided by 5. I'll pause while you punch those in. See if any, we'll see if anyone has that. Anybody can get an answer for that we can compare to someone else's version?
6.22.
Anybody get something different than that way? All right. Okay, good. 6.22. Something feels weird. You let's say something feels weird. When you guys added it up, did it add up to 31.1?
Yeah.
Yeah.
What is this 620? Oh, I see. I got it. From here to here, instead of them showing what 31.1 divided by 5 equals, which is the 622, they just went to the next step. So once we found the sum, or rather the mean, this is the mean of these guys, then they want us to take the square root of it as step 5. So step 5, which looks like I'm dividing, but I really am writing step 5 is to do my 6.22 and actually take the square root of that. Let's find out if it really does equal 2.5. When you get a chance, put in 6.22 and hit. If it does do it, okay.
It's actually like 2.5.
Oh, they just rounded it. Now, there are certain things you're going to see when you talk about standard deviation. In other words, certain things have their very own letter for when you're looking for it. Hey, please find the standard deviation. They will use this little symbol right here. That little symbol is, I want to say a baby sigma. I forgot the name. It's a Greek letter and it's lowercase. For whatever reason, my brain isn't coming up with the answer. It'll come back to me and be like, oh, I can't believe it. I know that this is capital sigma, which I actually want to highlight to you what that means. Well, let's find out. Over here, this is the official formula for all the stuff we just did. The distances, you see the x minus x bar. We see the square where we square them all. The question is, how do we show that we're going to find the mean? That we're going to add all these up and divide by how many of them there are, the n. That capital sigma is for adding together. If you see this capital E in front of something, it says, hey, you probably have more than one of these things, and I want you to add them all together. In this case, we have 5 of these. We'll add them all together and divide by how many there are. Dang it. All right. I think it's a lowercase sigma. Yeah. All right, pause. Hey, any of these steps, because you're about to try them all. I'm going to recommend making the chart on yours so that you keep things in order. This part here is where you add all these together so that when you're looking at this chart, you can see if I add all that stuff together, it gives me that 31.1. After you get your 31.1, you have to divide that by how many there are. I'm putting it near, it's this thing that's over here, and then ultimately, once you get that answer, which is a 6.22, then you'll take the square root of that to get that last line. All right, let's give it a shot. Please find the standard deviation on the other sheet that you have. And when you finish, I think it is sigma. I guess I gotta put a subtraction sign. Here. All right, so this one, the single sheet, that's not stapled, is called Stats Project Idea Career Choice. For those who aren't here when you get that single page, that's the title up here at the top. Of course, we did step one, which was take the career aptitude test. We did both versions, so less. Then it says pick a career cluster and read about individual careers that interest you. Of course, we've done that part. So we're moving along in the unit in terms of their goal. This single sheet kind of describes what the entire unit is trying to produce. This third and fourth step is what we're going to try and get a little bit more of. We've sort of started it, but we didn't write down numbers. And today, we're going to come away with at least 3 to 4 numbers in each category, and I'll show you some of mine. It says here, pick 3 to 5 specific careers you're interested in investigating further. And again, for number 3, for the purposes of this exercise, you can choose something, okay, I don't mind hearing that, or you can choose something semi-random within the cluster that was yours. Like mine was education, one cluster. One cluster was tourism. So I looked up something under tourism. So the job I looked up, after seeing how much you get paid and what you have to do, I kind of thought, nah, I don't know if I'd want to do that. But I have numbers. So when it's time for me to start doing some of the assignments, I have, how much they make, how many people are doing it. What's the percentage growth? Like, is it going to be growing or not? Nope, there aren't going to be any new positions because it's not growing. So step 3, when you pick three for this case, and I'm going to see how long it takes to do 3. You'll find them, and then this website, the www.bls. I'm going to have you open both sites. I opened both of them last night. One, I got the information off of CareerWise and its clusters. And then I went over to this one to see, do you guys give me the exact same information? And that kind of thing. So I'm going to have you do that and see what happens. Listen to 4. This is the big deal today. Pick pieces of data for each career cluster or occupation groups that would help you make an informed decision about what specific career may be right for you. Now again, that is believing that, okay, this is the choice, but for our purposes, if you had to choose an area that just to gather information, fine. It says pick at least 4 pieces of data you will use for your final decision. 3 pieces must be able to be displayed statistically. In other words, we need numbers, so we can get a standard deviation, or so we can get the mean, or we can find the rank, all those things. You need numbers. Research each piece of data. You will eventually be visually displaying this data. And we'll see what we'll do eventually with that. Maybe put in a pie chart, in a histogram, some sort of chart. The example pieces of data, pay, that one was easy. When you look on yours, I put an extra dot next to the ones that were obvious. Okay, they're going to be numbers when I find that. Education level needed. Oh, you need to finish high school. You need to finish college. Yeah, but it's not a number. Growth, job growth. I put a dot there. Job description. Hey, I put a dot there. Though clearly you can't find that with numbers. Number of jobs available. I put a dot there, though I think that one was a little difficult for me to find. Type of industry employed by, skills needed, no doubt, and that scribble that you see how to become one. On one of your handouts that we gave you last time, it asks you to write down, choose a job, describe it, and how to become it. So we're still going to fill that in either today or at another time. All right, so those are the standard deviation. I'm going to try and write on the board what the students have done. If I make a mistake, hopefully once or twice they'll peek up to see if you made a mistake. Step 1, we're going to make a little table. And on this table, so something to write it. The first thing is going to be our X. Those are the numbers that are given. In this case, 10, 12, 14, 16, 18. And then the next column over, I needed to get the mean. I snuck and looked at the papers. They added these numbers together. 14 in the middle happens to be the mean also. I hope they're right. Can anyone say what that total number was on the top that produced the 14? Is it 80 or something? They're peeking. They're doing 2 things. What's the total of these when you added them up? I know the mean came out to be 14. Remember what the top one was? All the time you guys just did. Alright.
17.
Thank you. So they got a 14, and on each row, they put down that 14. All right, so they put their 14 down. So we're getting the standard deviation. The next row over, they were finding the distance from their number to the mean. So they did a little subtraction. All right, let's see if I can do that subtraction in my head. Let's go with -4, -2, 0, regular 2, and a regular 4. Next row over, they square those numbers. Anyone have trouble getting into it? I'll try and help you guys get in there.
Thomas,
Yes.
do you have to have that or the exact numbers? Because I got 14.2.
Oh,
So it was like -4.2, and like there were decimals throughout the whole thing.
I would accept that. But does this add up to 70?
Yeah.
Because if it adds up to 70, I wonder, I think, hit 70 divided by 5 and see if something maybe was doing it, because it would seem like if it was just at 70, I know 5 goes at 70 evenly.
Yeah, mine came out to 14.2 a couple of times.
Did it do it again this last time? Or
No, this last time it didn't, but the other 3 times. Because I
What-
think I did it like 4 times and it came out to 14.2.
What I would say to you is I would keep what you have, knowing that you did the right steps, and obviously something triggered when you went to the calculator. And let's say you had your chart like this, I would be able to see, your pieces. I'd look and see, oh, okay. So yeah, I'm not sure why it would do that, but and so all the numbers are just off a little bit with the decimal.
Yeah, I think there's like a 0.2 after a lot of them.
Okay. And so this one, we add it together. I think we're on the stage where we add the squares. It gives us something. Those who had the 16s, what did it give us? That's a 32. What's that? That's an 8. 32, 40 rather. 40 that we're going to divide by 5. 40 divided by 5 happens to be, I think, 8. And then for that final step, we take the square root. Now here's what's a note or message for the students. The same way I didn't have to look at the signs, the steps, each one of them. If after you do it a lot of times, then it'll just sticks in your brain, which is 2.3 or 4. I'll put 2.3 and hopefully I'm right. And for that, hopefully we can put the sigma symbol. That is the standard deviation. At some other point we might dig deeper to see kind of what that was. 2.8? All right. Let's see, can I turn that 3 into an 8 without erasing? Nope. All right. So if there's any part of that standard deviation you need to review, obviously it'll be in the video or if you're going to ask. All right, for those who aren't here, I've gone to CareerWise to get pieces of data on at least one of the areas in my career in my cluster. One of them happened to be hospitality and tourism, so I just click there. Once I got there, I clicked on careers in this cluster. And then as I went down, I just looked at some of them. There are a bazillion of them in there. I actually thought of one that I could be interested in, so I didn't put down dishwasher. No, I just wasn't interested. Fast food cooks, no. When I got all the way down to, this is for those who aren't here, to recreation workers, I thought, okay, organize, conduct recreation activities in public facilities, okay. Recreation, I like playing. Let's see what that is. Now they have the quick facts, which fortunately have numbers. So on my paper, which you can't see on the screen, I wrote down the 1173. The growth rate, I wrote 12.1%, and I wrote what the title was next to it, so I know what that number was. Both I wrote down the word outlook and growth rate. I wrote down education, even though it's not a level. Now the only bad part, as you can see if you're looking at this video, is I want 4 numbers. They only have 2. So I think I looked up that job again on the BLS, which has more numbers. Right, that's what I wound up having to do. There are only 2 numbers on career-wise. So if you're watching still, I clicked over and I went to BLS, where they have more numbers, which the students in class are probably going to need to do as well. Let's see if we can get that. Oh, let's pause. So the next one was HTT. Yeah, so it is true. You're only going to get 2 pieces of information on that one, which is why. Now I see I have to go over to www.bls.gov/, or Occupational Outlook Handbook. Alright, let's see once that pops up. From here, the occupational groups, you can see they have different titles. The group in career-wise was hospitality and tourism, but here on the BLS, there's no H for hospitality or tourism, so the question is, how would I find that same job to be able to get some of its numbers? There should be a find button. Let's see. My screen, there it is, search handbook. And I typed in the same title, recreational worker. Hit enter. And from there, I was able to find it. Same thing for you guys here in the classroom. To get more numbers, there it is. See how many more numbers they have? They have 1, 2, 3, and 4. They have 4 numbers on the BLS. So you can find your names in career-wise and then plug it into the BLS, the other one. And so also, if you get to a word like employment change, and like I'm not even sure what that means, I think you can hit the question mark. Projected numeric change in employment from 24 to 2024. In other words, either how many more jobs or how many less jobs. I assume how many more jobs will be there. If it were a negative number, I assume that would mean it would be reduced by that amount. So again, the data, I would use these 4 categories. Also up here at the very top, how to become one. On one of the original handouts that we filled out on the back, it said choose one of the careers, and the second line said how to become one. This can be used to fill that one in when it's time. They have a lot of information on the back, so you won't have enough space for all of that. But All right, there you go.